we say that matter is conserved. And we're using the word conserved in a little different way than you think about conserving nature or preserving nature. Conservation of mass means that there is no new matter, or we can say matter is neither created nor destroyed in a chemical reaction. In a nuclear reaction, which we will talk about at the very, very end, significant changes in matter can occur. But until we get to chapter 17, we are not talking about nuclear chemistry. So in a chemical change, there are no significant changes in mass. The mass that you start with is the mass you end up with. Now, it may look very different. Think about building with Lego bricks. You can take the bricks apart. You could have a little man and a little woman, and you could take them apart and you could make a robot. Do they look different? Yes. Do you have the same blocks that you started with? Yeah. You can't take a long brick and make it into 2 bricks with your bare hands, right? So playing with Legos with your bare hands is like chemical changes. The individual bricks, the individual atoms cannot be altered. The nuclear change is if you take the Lego bricks into the garage and you use a hacksaw on them, or you melt them. That's not normal, though, is it? Shouldn't be. Shouldn't be. So in chemical reactions, we don't have any change in mass. Matter is conserved. Total amount of matter remains constant. It just gets rearranged. So if we had 58 grams of butane and 208 grams of oxygen, we burn the butane and it uses this oxygen. We started out with 266 grams of stuff. This is undergoing a chemical change. We don't have butane and oxygen anymore. We have carbon dioxide and water. The butane and oxygen molecules have been taken apart and the individual atoms put back together in a different way, but all the atoms are still there. And so the total mass of what we end up with is equal to the mass of what we started with. We do not always observe this, like if you think about burning a piece of wood in the fireplace, on those rare days when they actually let you burn wood in the fireplace, right? Mostly it's no burn days. Does the wood weigh less after it's burned? Yeah, there's ashes. So where did the rest of that mass go? It went into the air, it went up your chimney. Okay, so the cellulose and the other compounds in the wood that contain carbon react with oxygen in the air and they form carbon dioxide and water molecules and those float away. We don't see them floating away, we don't notice them. Does that mean that we destroyed matter? No, it just means we didn't account for everything. Okay, so in this example, if you do it in a controlled way where this is all contained and the chemical reaction occurs, the mass of this container will be the same as the mass of that container. You can't create mass or destroy mass with chemical changes. So there could be a question like this on the exam. And especially if you had like high school chemistry or you've taken this class before, students tend to make this way more difficult than necessary. We are not talking about stoichiometry or molar masses or anything like that. At this point in the class, I'm assuming that you know nothing about that. We're asking you to add and subtract only, okay? So we're keeping it simple here. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide and how many grams of water? It might be helpful to draw a picture. So we've got here the gas, the natural gas, and that's combining with oxygen. Okay, and they tell us how much. There's 12 grams of this and 48 grams of that. Those are the two things that are reacting. And that is producing, there's the arrow, it's producing some carbon dioxide. Carbon dioxide. I don't know why I'm writing with my finger. That's messy. And water. And it tells me that there's 33 grams of carbon dioxide. And it wants to know how much of this? 27. How'd you do that? Well, you put these two together. What was that, 60? The total mass you started with was 60 grams. The total mass you end up with has to be 60 grams. You can't create or destroy matter. And so then you're asking, well, what plus 33 equals 60? It's 60 minus 33, and so it's 27.
When we're told that there's oxygen, should we assume it's an element or a molecule?
Well, at this point, we don't need to know whether it's an element or a molecule. Later, that will become important, but not yet. You will know then, because I'm going to teach you how to know. But we don't know yet. Any other questions?